All right, guys, happy Monday. It is Miss Lastly and Miss Margaret, and we are here for day 6 of our matrices unit. Today, we're going to look at inverses and identity matrices. We're just going to basically learn what they are today, have you guys practice finding them, and then we'll start using them tomorrow. Ooh. All right, Miss Margaret, it's your turn.
So, like Miss Leslie said, we're starting off kind of easy this week, as some of you still have AP testing, I think. So we're going to look at the identity matrix today and then finding inverse of matrices, and hopefully it should be pretty easy. Your homework is pretty short, so hopefully today is not too bad. Yeah, okay. One thing that I will say before we get started is really keep track of what you're doing and pay attention, because this one can get just a little tedious. So just pay attention, like most things in math. But yeah. All right. So the first thing we need to talk about is the identity matrix, and this is a square matrix. And remember, square means that it has the same number of rows and columns, just like, I think, definition of a square. So same number of rows and columns, and it's a square matrix with ones along the diagonal and zeros everywhere else. So for instance, if we have, and this is denoted with just a capital I. So whenever you see a capital I when you're using matrices, that means that you're using the identity matrix. So if we have a 3 by 3 matrix, we're going to have 1, 0, 0, 0, 1, 0, 0, 0, 1. So as you can see here, we have ones along the diagonal and then zeros everywhere else. And so that's what your identity matrix is. So if we were to have a 2 by 2 matrix, we would have a 1, 0, 0, 1. So again, ones along the diagonal, zeros everywhere else. For a 1 by 1 matrix, you just have 1. Cool. Yes, this is a super useful matrix. So, yep. And then as you get matrices that are bigger, you just keep them on the diagonal and then zeros everywhere else. It's super easy. Okay. So then for properties with these identity matrices, we have the first one is that matrix A times the identity is equal to matrix A. So essentially, the identity matrix kind of works like 1 does in multiplication. So whenever you have whatever matrix you have, whatever identity matrix matches it, like in size matches it, it will equal matrix A. So for example, if we were to have A here, and this is equal to 3, 1, negative 2, 4. We have 1, 0, 0, 1. This is our identity matrix. And then this is going to end up equaling 3, 1, negative 2, 4. I don't have enough room to do all the math for you, but trust me, it works. If you want to prove it for yourself, you can go back and practice your matrix multiplication, but trust me, it works. So we can also just write the shorthand. So A times I equals I times A, and that equals A. Just like that. Cool. Okay, the last property we need to talk about is that 2. So number 2. So A times A inverse, and this is your inverse matrix of A. So inverse of matrix A. So when you multiply the original matrix times its inverse, it should equal your identity matrix. And that's how you can check and make sure that you got the right inverse matrix. So if you don't, when you're multiplying those two together, if you don't get the identity matrix, you did something funky. So that's a good way to check on your checkpoints, and you, I think, have to do it on tonight's homework, but I'm not sure. Maybe not. Okay. Anyways, it's a good way to check if you have the right answer or not. Okay, so really quick, This doesn't need as big of a space as I put it, but we're going to talk about the determinant really quick. This is super important when we talk about how to find the inverse. So I gave it its own little spot just so that you guys can see how to find it really quick. And then we'll talk about finding inverses. Okay, so if we have matrix A, and we have A, D, C, and B, then the determinant of A, and that's our notation, so this is our notation, is equal to AD minus BC. And this gets used for inverses. It's super simple. You just take AD minus BC, and then you should get one number, and that's super simple. But there it is. If you get confused and you see determinant somewhere, that's how you find the determinant. Okay. So to find the inverse of a 2x2 matrix, we are going to have our little a negative 1, a to the negative 1, and this is equal to 1 over the determinant of a. So that's where that piece comes in. And then you're going to take D, negative B, negative C, and A. So I know this looks funky. So A is the same as above. So A, C, and B. So what we did is we take, we swap the two and then we make these ones negative. So if you can see here, we have row here, we swapped them, and then you make the two corners negative. And I know that looks funky. And then you multiply it all by whatever your scalar is out front. So this right here should be a scalar. That's 1 over a number. Cool. Okay, let's do an example, and hopefully this will make more sense. I know it looks a little funky, but hopefully it will make more sense. Okay. So if we have our matrix here, so we're gonna find the determinant first. So the determinant of A is equal to AD minus BC. So we have, this is AD, C, and B, just so we can keep things straight. So we have 2, 0, minus negative 4 times 1. So we have 0 minus, plus 4. No, that's not right.
Yeah.
Sorry, guys. Hang on.
Letters.
What did I write down? Okay, so I figured out where I went wrong. Sorry, guys. B and D look very similar. I apologize for any confusion. It now makes way more sense. So you're going to go just alphabetically A, B, C, D, and then apparently they look very similar. Sorry. Okay, so we have, for our determinant, we have AD minus BC. So we have 2 times 1 minus 0 times negative 4, and this equals 2. Okay, cool. I have everything fixed, so hopefully I didn't confuse you guys immensely. I confused myself, but it's fine. Okay, so 1 over the determinant. And then we need to swap on the diagonal and then make the other two opposite signs. So we're gonna swap here. So we're just gonna swap those. So we're gonna get 1, 2, and then on, let's do this diagonal, we're gonna, no, I did that wrong. Sorry, guys. On the pink diagonal, we're gonna swap the signs. We're gonna get 4, 0, because 0 doesn't swap. It's just a number. And then on the blue diagonal, we're gonna swap the two numbers. So this is the blue diagonal. This is your opposite sign diagonal. And then you're going to multiply out by the scalar. So we should get, as a result, 1/2, 0, 2, 1. So to check that they are, in fact, inverses of each other, we're going to take A times A inverse equals I. And you're just going to multiply them together. So 2, 0, -4, 1 times 1/2. 2, 0, 1. So remember matrix multiplication, so row by column. So we're going to have 2, 1/2 plus 0, 2 equals 1. 2 times 0 plus 0 times 1 equals 0. -4 times 1/2 plus 1 times 2 equals 2. Nope, that equals 0, sorry. I don't know why I said 2. And -4 times 0 plus 1 times 1 equals 1. So we do, in fact, get our identity matrix, so we did that right. Okay, let me put in the homework for tonight's thing, and I'm going to go over one more example, and hopefully it will make more sense. So let's do one more example, and then we should be good to go. Okay. Let's do number 8. Okay, so the first thing that we need to do here is find the determinant of A. So the determinant of A equals AD minus BC. So we're going to get, let's just label this really quick. So A, B, C, and D. And we have -6, -10, minus 10 times 5. And so our determinant is 10. To find our inverse, we're going to take A inverse, and that's equal to 1 over our determinant. And then so when we have our blue diagonal here, we're going to swap those two numbers. So we're going to have -10, -6. And then on our pink one, we are going to make those opposite signs. So we're going to get -10, -5. And then you're just going to multiply out by your scalar, and you're going to end up with -1, -1/2, -1, -2/5, I think. Okay, hopefully that one made more sense. So just remember on the pink diagonal, you're just swapping signs. And then on the blue diagonal, you're switching places. So yeah, hopefully that makes sense.
Yeah. Cool. All right, guys, that is it for identity matrices and 2x2 inverses. For this class, the only thing you're gonna have to do by hand are the 2x2 inverses, and we will talk, I think tomorrow, is it tomorrow we do calculator stuff, or Wednesday?
I think it's
Wednesday. All right, so on Wednesday, we're actually gonna go over how to do inverses of larger matrices, like 3x3 matrices, using your calculator, because it is not something that you want to do by hand. I usually make them do it by hand, but I won't make you guys, I'm not making you guys do it this year, so you're very welcome. Anyways, we will see you guys tomorrow for some application of using some of our tools that we've done so far, like adding, subtracting, multiplying, using inverses, things like that. But yeah, that's it for today. So that is inverses of 2x2 matrices and identity matrices. For those of you taking AP tests today, I guess, good luck, and hope you guys do well. See you tomorrow.